Alright, so we got another one of our prereq skills here. It's more writing equations of lines, and there's some slope in here. So this first question here is find the equation of a line that passes through the point 1, 5 with a slope of negative 1/3. Write your answer in both slope intercept form and standard form. So slope intercept form would be something that your Algebra 1 teacher would have gone over with you. If you forgot it, there you go, write it down. And odds are good that you forgot it. Because, well, I've done this a while, so pretty good chance you forgot it. So we're going to plug into this formula, and our point is going to give us this x1 and y1 value. And of course we have our slope here. Now, do not be the kid who forgot that m is the abbreviation we use for slope. I don't know why it's the letter m, it just is, but that's the abbreviation we use for slope. Now, the y by itself doesn't get replaced with anything, but it's y minus y1, and y1 has a value of 5. So y minus 5 equals m, which is negative 1/3, times x minus x1, which is a 1. Now, this is the, well, it's not done yet. This is point slope form. So we want to write our answer in slope intercept form and then standard form. To get to slope intercept form, which you may or may not remember is y equals mx plus b, we're going to have to use the distributive property. So we're going to distribute that negative 1/3. Negative 1/3 times x is negative 1/3 x. A negative times a negative is positive, and 1 times anything is whatever that anything was. Now we're going to add 5 to both sides, and I realize that, doing addition for some of y'all is pretty tough, but it's kind of sad if you can't figure out what 1/3 plus 5 is. Like, you're juniors, man. I guess you'd probably say 5 1/3. I like mixed fractions. So I'm going to change that that 5 into a 15/3. So 1 plus 15 is 16. This ends up being 16/3. You need to know how to work with fractions, kids. You're going to graduate high school in a year and a half. Figure them out. And there we go. That is slope intercept form. That's my slope intercept form goal. My next goal is standard or general. That's the ax plus by equals c, where a is a positive integer. Now, if you'll pay attention, you'll notice that the x's are on the left in front of the y. So we're just going to simply start off by moving this over here. And that'll give us 1/3 x, and it's going to be positive because it jumped equality, plus y equals 16/3, because the 16/3 was just left by itself on the right-hand side. Now, it's supposed to be a positive integer. A third is not an integer. That's a rational number. To make it an integer, we're going to do the opposite of division, and the opposite of division is multiplication. And if I only multiply that term by 3, I break balance. So I actually have to multiply all the terms by 3. That's called equality. Balancing, well, I'm tired. I have to do it for balance. Anyways, 1/3 of 3 is 1. So just a singular x. 3 times y is 3y. And, again, a lot of this is a pretty big deal that you remember your 5th grade math. If you do 3 times 16/3, the 3's cancel. And that is general form or standard form. One down, 6 slides to go. A line passes through the points negative 1, 3, and 5, negative 1. Write the equation of this line in point slope form, slope intercept form, general, and vertex. Now, one thing I didn't mention on this particular slide is I'm kind of hoping you remember the formula for slope, and sadly a lot of kids don't. It's really sad, but the formula for slope is y2 minus y1 over x2 minus x1. And we'll get the x1 and y1 from this point, and we'll get the x2 and y2 from that point. And then we'll just plug into the formula and we'll go to town with it. Alright, so what do we have here? We have negative 1 minus 3, sitting pretty over 5 minus a negative 1. Negative 1 minus 3 is going to be a negative 4, and 5 minus a negative 1 is 6. and negative 4/6 will reduce down to negative 2/3. So the slope that I'm going to be using is a negative 2/3. Now this one wants point slope form. It's as simple as plugging things in, okay? And we'll just use that pair right there. You can pick either pair you want, but I'm just going to use that pair. We'll have y minus 3, because that's the y1 value, equals negative 2/3 of x minus a negative 1. Now, taking away a negative is addition. So, there's my equation in point slope form. To get to slope intercept form, you just have to kick it with a distributive property and combine like terms. So if I was to distribute that negative 2/3, I'd have negative 2/3 x minus 2/3, and it'd be y minus 3 equal to that. Remember, I need a singular y all by its lonesome on the left-hand side. All I have to do is I have to add that 3 to both sides. So I need to figure out what negative 2/3 plus 3 is. So I'm going to introduce a 3 in the denominator, and if I do it to the denominator, I have to introduce it to the numerator. And 3 times 3 is 9, so negative 2/3 plus 9/3 is what I'm looking for. And 9 plus a negative 2 is 7. So here is my slope intercept form. Negative 2 plus 9, 7, both pieces over 3, 7/3. Alright, now on to general and standard form. Ax plus by equals c, where a is a positive integer. Just did one of these a few minutes ago. This has to be moved over. It will become positive since it was negative. 7/3 isn't going anywhere. And the opposite of division is multiplication, but you can't just multiply one thing by 3, because if you do that, you break balance, you break equality. So you're going to have to triple all 3 pieces. So 3 times 2/3, the 3's will cancel out. That will leave me with 2x. 3 times y is still 3y. And 3 times 7/3, and again, you need to learn how to use that blank space in your head. 3's cancel. It would equal 7. Last up is vertex form, and I've never actually seen anybody try to teach vertex form with lines, and I don't know why they don't, because in Algebra 2, vertex form is huge. So do it with lines, just to get your kids exposed to it. Now, in vertex form, this is your slope. And h and k are just some point on the graph. That's all they are. H and k is just some point. That's all they are. We're just going to use that one. So I'm going to take that ordered pair, negative 1, 3, and I'm going to let the negative 1 be h, and I'm going to let the k be 3. And I'm just going to plug it in. I don't have to manipulate anything I've already done. I've got points to use. So this becomes y equals, has slope of negative 2/3. H is negative 1, and this goes x minus h, so it's actually x minus a negative 1. And then plus k, because that's what it says, so plus 3. And we'll clean it up a little bit. Y equals negative 2/3 lost my place there, x plus 1 plus 3. And notice how it looks a lot like point slope form. I'm a little at a loss as to why point slope form is actually still taught. I think we should probably in mathematics move straight over to just vertex form and be done with it. They're really the same thing. Alright, find an equation of a line that passes through negative 5, 2 and has a slope of 2. So, and it doesn't actually say how you want this one's supposed to be done. We're just going to do y equals mx plus b form. And, I haven't shown it yet in this video, but you can use y equals mx plus b to do these things. Because an ordered pair will give you an x and a y, and there's your slope. So let's do this using y equals mx plus b as opposed to point slope form, okay? I'm going to plug in a 2 for y. I'm going to plug in a 2 for slope, m. I've encountered an x, I'm going to let it be negative 5. And then I have my plus b. Also, I guess worth talking about here, that b is your y-intercept. That's what it is. And plugging in those 3 things has made me able to figure out what the b value is. So 2 times negative 5 is a negative 10. And the opposite of being negative is addition. So we're going to add 10 to both sides. And that'll give us 12. So my y-intercept happens on the y-axis 12 units in the sky. And my equation is now y equals, follow mx plus b, 2x plus 12. Now, it says find an equation of a line perpendicular. Please remember your notation for perpendicular to your line above that passes through the same point. So I've got down here in the box, because most kids have forgotten by now the deal with being perpendicular. Perpendicular slopes have opposite reciprocal slopes. They are opposite reciprocals. So we had a slope of 2. It's up here. The perpendicular slope would have the opposite sign, which makes it negative because it was positive. And reciprocal means flip to some degree. It'd be 1/2. So we're going to do the same thing we just did with the same stuff because it's passing through the same point, and we're going to find the equation of the line that's perpendicular to it. So again, just plug into y equals mx plus b. A y value is going to be 2. Your slope is now negative 1/2. The x value is still negative 5. And since it's perpendicular, we don't know where it crosses the y-axis. It's probably going to cross the y-axis, so negative 5, 2, up there. It's probably going to have a negative y-intercept. That would make sense to me based on visualizing it. Okay, so this one's got fractions, so it's a little rougher. Negative times negative is positive. 1 times 5 is 5, so this is 5/2. So 2 equals 5/2 plus b. And we're going to subtract the 5/2. So we have to figure out what 2 minus 5/2 actually is. So 2 is 4/2. So the question is, what is 4/2 minus 5/2? And that's negative 1/2. So negative 1/2 is my y-intercept. And I was kind of telling you visually that made sense to me. And turns out I was right. So y equals mx plus b again. Our slope was negative 1/2. And we found that we had a y-intercept of negative 1/2. Easy peasy, lemon squeezy. A line is perpendicular to 4x minus 8y equals 12 at the x-axis. Find an equation for this line. So what they're telling us in the text is that wherever this line crosses the x-axis, that's where the perpendicularity is happening. But anyways, we're supposed to find an equation for this line. So I guess the best way to explain this one would probably be to graph the original line. So let's take a look at 4x minus 8y equals 12. And we're going to find its x-intercept. And to find an x-intercept, we let y equal 0. So 4x minus 8 zeros is 12. And this tells me that the x value is 3. So this thing crosses the x-axis at 3, 0. That's where the original line crosses it. I'm going to go ahead and finish it and figure out the y-intercept and stuff too. To find a y-intercept, we let x be 0. So 4 zeros minus 8 y's is 12. This is gone now. We divide by negative 8. And we reduce the fraction. We have a y-intercept. Those are both divisible by 4 at negative 3/2. And this is what the line looks like, okay? But the line does pass through 3, 0. Now, what's its slope? I guess you could look at the graph and figure it out if you wanted to. Most people will take a given equation and they'll rewrite it in y equals mx plus b form. So we can do that by subtracting 4x from both sides. Negative 8y is now equal to negative 4x plus a 12. And then dividing out the negativity. And when we do that, we'll have that the slope is actually 1/2. So 1/2 x minus 3/2. But I wanted that. I wanted the slope. Now, the slope of the given line is 1/2. The perpendicular slope is the opposite reciprocal. So you're going to have to flip the sign. Instead of being positive, it's going to be negative. And you're going to have to flip the number, 2. So let's think about what we have. We have a slope. We have a point. And I want to do this one with point-slope form. I'm trying to show you multiple ways of doing things, but we're going to use point-slope form. So point-slope form is y minus y1 equals m times x minus x1. We have a slope of negative 2. The x value is 3. The y value is 0. And all we got to do is kick the right-hand side with the distributive property, and this thing is done. Negative 2 times x is negative 2x. Negative times negative is positive. 2 times 3 is 6. And there is your perpendicular line, okay? All right, 3 slides to go. I'll be right back. I'm going to pause for a second. All right, I'm back. The line is perpendicular to 6x plus 2y equals 20 at 3, 1. Okay. Write an equation for this line in slope-intercept form, standard form, and an equivalent vertex form. So there's lots of stuff to do here. The nice thing is we already have a point here. Now, on the last one I had to figure out the point. In this one I do not have to figure out the point. So to write an equation of a line, I need to know its slope, and I need a point. And I have the point. So let's go ahead and look at this one real quick, the given line, and let's modify it to look like y equals mx plus b so that we can kind of steal its slope and manipulate it and end up with our desired slope. So I subtracted 6x from both sides. Now I'm going to divide everything by the 2. And the original line in slope-intercept form is y equals negative 3x plus 10. So the original slope is negative 3. Now I am going to be perpendicular to it. So remember, it's about being the opposite reciprocal. The opposite of a negative 3 is a positive, and the reciprocal of 3 is the third. So here we go. Slope, point. Okay? And I'm going to use point-slope form to do this. I'm going to plug into y minus y1 equals m times x minus x1. So y minus 1 equals 1/3 of x minus 3. And the numbers on this one are kind of nice. I mean, they work out. 1/3 of 3 is 1. So y minus 1 equals 1/3 x minus 1. It's not in slope-intercept form yet. Slope-intercept form is y equals mx plus b. Something cool on this one, if you just add the 1 to both sides, the constants cancel each other out. And there's your equation. So there is slope-intercept form. Let's do standard form. We're just going to move that 1/3 x over. That will make it change its sign. Negative 1/3 x plus y is now equal to 0 because there's nothing on the right-hand side. And every example in this lesson has been the same thing. The opposite of division is multiplication, so you had best 3 everything. Even at 0, but 3 times 0 is still 0. 3 times a negative 1/3 is going to be a negative x. 3 times a y is plus a 3y. Now, in standard form, this piece is supposed to be positive. Okay, so to make it positive, we're going to take our equation and we're going to divide the negativity out, and that will make the x piece positive. But now everything has to be divided by the negative 1. And we'll have x minus 3y equals nothing. All right, that is standard form. We're supposed to write an equivalent vertex form. So remember, this is the original, okay? I am going to simply write down vertex form. And that's my slope, by the way. I have a slope of 1/3. I pass through this point. This would be h, this would be k. And I'm done. That's how hard that was. Don't ask me why, there's an e there. Last one and we're done. the lines x equals -2, y equals 6, and y equals 2x minus 7, and y equals 2x plus 4 form a blank when graphed. Find the area of this geometric figure. Seems like this one's not supposed to be in here. So we're going to get rid of it. Alright, we're going to need a grid. I thought I had modified this problem. See, I have to have down a 7, so I need to go farther. X equals -2, that's a vertical line. You guys know that. It crosses the x-axis at -2. Y equals 6 is a horizontal line, crosses the y-axis at y equals 6. Then you have 2x minus 7. It has a y-intercept of -7. It has a slope of 2. And I'm going to actually need to go down farther. It has a slope of 2. So it's going to rise 2 and run 1. Rise 2, run 1, rise 2, run 1. I'm going to do lots of dots to make sure I try and hit their spot best. Okay, so it's going to hit about right there. I did not leave myself enough room, I think, for down here. I didn't. Oh well. Now, I need to figure out where these things intersect. Now, I did form a triangle. Okay? Happens to be a right triangle with that, because those guys are perpendicular to each other. We have an intersection here at -2, 6. We have an intersection here at 3, 6.5. So 6.56. And this one here we're going to have to kind of extrapolate. This was 7, 8, 9, 10. It would be down 11 units because we hadn't quite made it, but we were falling 2 and running 1. So it would have been down 11 units. So the last intersection down here is happening at -2, -11. Now, I'm supposed to find the area of this triangle. And the area of a triangle is 1/2 base times height. And I know a lot of kids don't know that formula, and I'm awed every year that you guys don't want to memorize anything. You have to focus on memorization. But anywho, if this triangle was reoriented a little bit, this would be your base and this would be your height. Now, the difference between 6 and -11 is 17 units. So the triangle is 17 units tall. The difference between -2 and 6.5 is 8.5. So that is the base length. So the area of this triangle is 1/2 a base length of 8.5 times a height of 17. Yeah, give me a minute on that one. So we'd have 80, 56 is 136, and 8.5, 144.5. It should be 72.25, but I need to be checked because I haven't quite woke up yet this morning. And if I'm wrong, I'm wrong. Like, I don't care if I'm wrong. If I'm wrong, I'm wrong. It's okay to make mistakes. So we had 0.5 times 8.5, 0.5 being the half. And then we had to multiply that by 17. Yeah, 72.25. There you go. It's technically 72.25 square units. And that is it for Prerequisites Part 2. I hope you enjoyed. Of course, I know the reality of it. You're watching a math video. It's unlikely you enjoyed it. But anyways, have a good day.